Scientists have discovered the true ferocity of a huge volcanic eruption off the coast of Tonga in January.
The largest underwater volcano is finally exploding and cracking up the Earth. Since they could be dangerous, volcanoes are best observed from a safe distance. The fact that volcanoes' explosions can occur underwater may not be well known to many people who have seen footage of photos of volcanoes. What causes undersea volcanoes? What do they look like? And can they have an effect on you on land? In this video, we present to you the horrifying findings revealed by scientists on underwater supervolcanoes. A volcanic explosion is one of the most amazing natural phenomena. Even stopping or preventing them is impossible. But what exactly are volcanoes and how do they erupt? Enter a little fascinating geography now. The Earth's crust is folded, faulted, elevated, and eroded to create many mountains. But lava that has been released into the air slowly gathers to form volcanic topography. A cone or shield-shaped mountain summit may have a minor dip in the shape of a vent. The vent is connected to one or more interconnected storage places of molten or partially molten rock or magma by a network of fissures inside and beneath the volcano. The volcano can erupt repeatedly in the same spot thanks to its connection to new magma. The volcano enlarges itself in this manner until it becomes unstable. As a result of rock falls or landslides, pieces of the volcano collapse. Magma is the term for molten rock that rises from volcanic vents beneath the Earth's surface. When a volcano erupts, it changes into lava. Imagine an unopened soda bottle with sand inside as magma. It is composed of molten rock, crystals, and dissolved gas. The elements oxygen, silicon, aluminum, iron, magnesium, calcium, sodium, potassium, titanium, and manganese make up the molten rock. When liquid lava cools, different mineral crystals may develop before it solidifies and turns into igneous or magmatic rock. Magma, which has its origins several tens of miles below the surface, is lighter than the solid rock around it. Because it is lighter than the nearby rock, and because of internal gas pressure, it is propelled towards the surface of the Earth by buoyancy. Magma pushes its way upward and might eventually pierce the Earth's crust where it is weak. Then an eruption starts. There are numerous ways for magma to erupt. On occasion, molten rock can be seen pouring from the vent as lava flows. Additionally, it has the ability to erupt violently into the air as dense clouds of rock fragments, or tephra, and gas. Greater fragments return to the vent area, and tephra clouds may descend the volcano's slope due to gravity. Tephra fragments the size of a human hair, such as ash, may be transported by the wind and land hundreds of miles distant. Before they hit the ground, even the smallest ash particles may be launched kilometers into the air and transported across the globe by winds located high in the atmosphere. How many volcanoes exist then? More than 160 active and potentially active volcanoes are monitored by the U.S. Geological Survey, USGS, in just the U.S. Worldwide, there are around 1,350 volcanoes that could be active. In the last 100 years, almost 500 of these have erupted. The Ring of Fire, which surrounds the Pacific Ocean, is where many of these are found. A certain kind of volcano is excluded from the list above. It is a subaquatic volcano. Because they typically occur far away, you might not be aware of these underwater volcanoes. They are still dangerous despite this, though. The majority of volcanic activity actually takes place underwater. The deep sea is where 2/3 of all volcanic activity takes place. So how does a volcano under the sea form? Actually, there is no distinction between on-land, subaerial, and subsurface volcanoes in terms of how they form. When molten rock is generated in the second layer of the Earth's interior and penetrates the crust, underwater volcanoes can also form. The majority of undersea volcanism, according to Tamsin Mather, a volcanologist and professor of earth sciences at the University of Oxford, is connected to the continually active volcanism among mid-ocean ridges, where two tectonic plates are separating. A volcano can also develop as a result of the two plates colliding. Hilo explained that if both tectonic plates are submerged, the volcano will erupt underwater. They might develop into volcanic islands in the future, he noted. A volcano can also be created by volcanic activity on one tectonic plate only. Hawaii and other chains of volcanic islands can result from a hotspot under an oceanic plate. You may be curious as to what transpires if a volcano explodes underwater. Depending on how close it is to the water's surface, an underwater volcano eruption might have different effects. The weight of the surrounding water acts as a pressure cap if the eruption occurs at extremely vast depths underwater. For instance, if a chunk of molten rock falls into the ocean at a depth of 2 kilometers (1.2 miles), it will come into touch with the chilly seawater and rapidly cool. Even though the water becomes quite hot, it will not become steam. If the water is shallow enough, the narrative changes. There is a significant volume change as a result of the water becoming heated by the magma and then turning into steam. Because only a small amount of water is required to create a large amount of steam, steam explosions can be quite damaging. The amount of ash released into the air when an undersea volcano erupts in shallow water can have a negative influence on people's health, in addition to the tsunami risk. In addition to polluting the air, the falling ash and released gases can also make it difficult to access water and electrical sources. Submarine volcanoes present a variety of challenges for research because they are submerged. Only a small number of active locations have been thoroughly investigated due to their inherent inaccessibility. However, by visiting the volcano site and collecting information, scientists operating on land can learn about a volcano's past. Cliff sequences or digging holes and gathering materials can be used for this. Scientists typically have to rely on marine surveys and mapping equipment like sonar for undersea volcanoes. The spectacular undersea volcanic eruptions that have occurred will be the subject of our next discussion. Let us examine the strongest underwater volcano ever discovered. In 2018, the greatest active underwater eruption ever observed gave birth to a massive underwater volcano the size of a building. The eruption's insane aspect is that researchers are continuously learning new things about it. What have they found out? A curious string of earthquakes that occurred close to what is often a seismically quiet area led scientists to the 820-meter-tall, 2,690-foot volcano in the western Indian Ocean off Madagascar. The scientists discovered a new submerged volcano that was nearly 1.5 times as tall as New York's One World Trade Center, after collecting geological data, including information from an underwater survey of the area conducted in 2019. Additionally, this new volcano derives its fuel from the largest known pool of volcanic magma. The magma source or reservoir is very deep, around 34 miles or 55 kilometers down, according to lead researcher Nathalie Foyer, a marine geoscientist at the Paris Institute of Earth Physics, IPGP, at the University of Paris. They were able to observe such a large reservoir at the base of the lithosphere, the outer layer of the Earth that comprises the upper mantle and crust, for the first time in the history of volcanology. Mayotte, a little island and French colony between Madagascar and Mozambique, was shaken by more than 11,000 earthquakes that could be detected between May 2018 and May 2021. The strongest earthquake had a magnitude of 5.9, but there were also unusual seismic hums, sometimes known as very low-frequency earthquakes, that began deep down and were detected by seismometers all around the world. Volcanic activity is linked to these extremely rare earthquakes. Given that only 2 earthquakes have been found nearby Mayotte since 1972, and that the most recent volcanic activity was last seen at least 4,000 years ago, this sudden seismic activity was unexpected. Scientists were astounded in July 2018 to learn that Mayotte was moving eastward at a rate of roughly 7.8 inches, 20 centimeters, per year, as determined by GPS data. Scientists erected global positioning systems and ocean-bottom seismometers around the island to better understand the geological changes taking place there, since the island had only 3 or 4 GPS stations at the time. The results were astounding. Between February and May 2019, Seismometers installed at both land and ocean bottom recorded 17,000 occurrences. Boyer and her colleagues boarded a research vessel on a trip to discover more about the subaquatic volcano. The crew was aware of a magmatic event east of Mayotte, but it was unclear whether the magma had erupted into the seafloor or remained buried deep within the crust. Ocean bottom seismometers, or OBS, record seismic signals, and Foyer revealed that they established a system to analyze those data. The teams worked shift by shift, round the clock, and in less than 2 weeks, they were able to pinpoint the locations of over 800 of the strongest earthquakes with magnitudes between 3.5 and 4.9. Most of these earthquakes were discovered within a radius of 10 kilometers, 6 miles, or less from the island's east coast. But they were deep, between 20 and 50 kilometers, 12 to 31 miles deep. This volcano produced a volume of material 30 to 1,000 times more than other known deep-sea eruptions. It is considerably bigger than both the 2012 Havre eruption in New Zealand and the 2014 Bardarbunga eruption in Iceland, which was the biggest eruption in Iceland in the previous 200 years. The group is keeping an eye out for further earthquakes and volcanic eruptions in the area. Comment below and let us know what you think about underwater volcanoes.